Si solid plus 2CH3Cl in presence of copper powder as catalyst at 300 degrees Celsius. The product is CH3 whole 2 SiCl2. The other reactions are RMgCl, that is known as Grignard reagent, plus SiCl4. The products are RSiCl3 plus MgCl2. 2RMgCl plus SiCl4 may give R2SiCl2 plus 2MgCl2. Also, 3RMgCl plus SiCl4 may give R3SiCl plus 3MgCl2 also. Where R can be any alkyl or aryl group. Silicones are prepared by hydrolysis of these alkyl or aryl substituted chlorosilane. For example, A. Hydrolysis of R2SiCl2. As shown below, RRSiClCl undergoes hydrolysis. The product is RRSiOH. The product will undergo polymerization as given below. So the two molecules of R2SiOH whole 2 as shown in the equation combine to eliminate a molecule of water, and we get a bigger product. That is a type of silicon. This process may continue to give a long chain polymer, but ends of the chain will be occupied by OH groups. B. Hydrolysis of R3SiCl. R3SiCl on hydrolysis will form R3SiOH. Now, two molecules of the product will unite to give another product, that is a type of silicon as shown below. Such a product cannot undergo further polymerization because there are no OH groups at the ends. C. Hydrolysis of a mixture of R3SiCl and R2SiCl2. These two compounds can give their own silicons as shown in the hydrolysis B and A respectively. Besides that, the growth of the chain of R2SiOH whole 2 polymer may be blocked at one or both the ends by R3SiOH. For example, the reaction given below gives a bigger polymer, one end of that is still occupied by OH. D. Hydrolysis of RSiCl3. This compound on hydrolysis gives cross-linked silicons. This can be explained in the following three steps. In step A, RSiCl3 undergoes hydrolysis to give RSiOH whole 3. In the step B, two molecules of SiOH3 unite with the elimination of a molecule of water to form a silicon whose both the ends are occupied by OH groups. C step gives a cross-linked polymer or cross-linked silicon as shown below. Properties of silicons. Number 1. The lower silicons are oily liquids, but higher members are waxy and rubber, that is elastomers, like solids. Second, these are resistant to heat, oxidation, and most of the chemical reagents have no action on them. Third, these are strong water repellents. Fourth, these are good electrical insulators. For example, silicon oil is used as insulating material in high voltage transformers. Fifth, these are non-toxic and non-sticking materials. Well, let us now answer some questions related to carbon and silicon compounds. So here is question number 1 as an objective question. The question is, which is the correct order of stability of carbon tetrahalides? The options are A. CF4 more than CCl4 more than CBr4 more than CI4. B. CCl4 more than CF4 more than CBr4 more than CI4. C. CI4 more than CBr4 more than CF4 more than CCl4. D. CCl4 more than CBr4 more than CF4 more than CI4. Answer. The correct answer is A. It is due to the following values of CX bond energies, which are in terms of kilojoule per mole. For CF it is 485, CCl 327, CBr 285, CI is 213. Question number 2. SiO4 4- ion exists, but CO4 4- does not. Why? The answer is, it is probably due to small size of carbon, due to which negatively charged oxygen atoms at the 4 vertices of tetrahedron will be very close to one another. The repulsion among them will not stabilize CO4 4- ion. That's why in place of CO4 4-, carbonate ion becomes CO3 2-. Question number 3. Carbon atoms show catenation, but silicon does not. Why? The answer is, to answer this question, we must compare the bond energies. For that, the values are given below in terms of kilojoule per mole. So for carbon-carbon bond, the value is 356. For carbon-oxygen, 336. Silicon-silicon, 226. Silicon-oxygen, 368. Thus, thermal stability of C whole end chains is high because carbon-carbon and carbon-oxygen bond energies are almost similar. Whereas in case of silicon, the SiO bond is stronger than Si bond. Hence, with the help of necessary activation energy, compounds containing Si bonds are converted very exothermally into compounds containing SiO bonds. That's why neither silicates nor silicones contain Si bonds. Question number 4. What is the reaction between alkali metals and carbon monoxide? Answer. Carbon monoxide reacts with alkali metals in liquid ammonia to give metal carbonyls. These are white solids containing OCCO with 2 negative charge ions. The sodium forms Na2C2O2. Question number 5 is an objective question. The question is, which is true regarding carbon-oxygen bond length? The options are A. Same in COCl2 and acetone. B. More in COCl2 than in acetone. C. More in acetone than in COCl2. D. COCl2 does not contain carbon-oxygen bond. The answer is, the correct answer is B. The bond lengths are as shown below: 1.21 angstrom in acetone and 1.15 angstrom in carbonyl chloride.